So the two problems where you saw the value of A change were in number 2 and number 3 compared to the first parent function, right? So here you should have had these values for A, H, and here these ones. The vertex was still at 0, 0. And then this one still opened up, but in number 3 it opened down. Okay? So what did you guys determine about what A does to the graph of the function? Okay, so one major thing that A does is determines if it opens up or down. So to look ahead a little bit at the questions that you guys answered. Not going to worry so much about why the person called it the rebound function, but you guys kind of get the idea based on how it looks, right? So how can you predict whether the graph opens up or down? This is determined by the A value.
Wait, so was the answer to A like yes, you agree?
Well, it's up to you.
Well, I don't know.
Okay, that's okay. All right, so the A value determines if it opens up or down based on, meaning if A is positive, it's opening up, meaning A is negative, it's opening. Okay? All right, what else did A control? CJ? Okay, so he's saying it also controls the slope of the lines. Did you guys see that when you graphed it? So the first parent function that you graphed kind of looked like this on your graph, okay, going through this. Then when you graphed the one that had a 3 as the A value instead of a 1, it was much steeper looking like this. Okay, like maybe those lines had a slope of up 3 over 1 instead of up 1 over 1. Okay, so he's saying that it's also controlling the slopes of the lines or kind of the steepness or narrowness of the V that you see. We're going to clean up that vocabulary like next unit and talk about the official names for all of that, but not quite yet here. So summarize how A affects the graph of the function. I would make an arrow up to part B where we talked about how A decides if it opens it up or down. And then I would also say that it changes the slopes of the lines. Okay, causing our V to either look wider or narrower as we view it. Okay, but if you view the V as two separate lines, it makes those lines have different slopes. Okay? All right, then let's talk about H. No, sorry, let's talk about K first. K is actually easier than H. H has this one little thing about it that's kind of weird, right? All right, so in these values, you should have had A was 1 for each of these because we weren't exploring A anymore. H was 0 because there was no change happening within the absolute value. But outside the absolute value, you saw a +1 and a -4. And both of these opened upward, which isn't surprising now that we understand how A operates. But the vertex was no longer 0, 0. Here it was 0, 1, and here it was 0, -4. So how does the K value affect the graph of the absolute value function? Good. It affects the position of the vertex specifically on the y-axis. So we can kind of say this two ways. One way is very clearly that the numbers show up as the y-coordinate of the vertex. And then what do you call it? What did you call it in geometry, the transformation where things were moved up or down? Translation, right? So we would call it a translation. Shift is another word for that, but translation is kind of the more proper word. And it's specifically, is it horizontal or vertical? Vertical, because K is only affecting the y-coordinates. Y-coordinates are how we move up or down on the graph. So it specifically is affecting a vertical translation. So it causes a vertical translation, and the way we see that show up in the numbers is we see the y-coordinate of the vertex from that K value. So let's write that down as how K affects the graph. Not what I want. Okay, so how K affects the graph. It causes a vertical translation. If you aren't sure what those words mean, you need to write next to that. It shifts the graph up and down. It also gives you the y-coordinate because it shifted up or down from 0. So if it shifted it down 4 from 0, it's automatically negative 4. So we know that y-coordinate will always match the k value of the vertex. Okay. Okay. All right. Then let's talk about h. So a is 1, k is 0 in these because we're not looking at k. They're going upward. What is the h value in number 6? Good, negative 3. This gets a little tricky because the general formula, inside the absolute values, does it say x plus h or x minus h? X minus something that we're calling h. So in this case, what number would you put in here for h so that when this simplifies, it looks like x plus 3? Negative 3. If you put a positive 3 in, it doesn't look like x plus 3. It looks like x minus 3. So that's really important to remember about that h value, or that value that's inside of the function. K is easier. The ones outside the function kind of behave how we would expect, but the stuff inside the function operates a little more strangely. Okay? So here, and then some of you guys were probably thinking, like, why wouldn't they just put a plus sign in the general formula? But hopefully, when you saw the graphs of this, you understood why they really want h to be negative 3 here, and why they really want it to be positive 2 here. Because what did you see happen to the graph of the parent function when you graphed number 6? How did the graph change from the first one? Good, it shifted to the left 3. So do you see why you think they're crazy, but why they put the minus sign in the formula? They want the number you pull out to match the transformation that you're seeing on the graph. If they left this a plus in the formula, you would have pulled out a positive 3, but the graph would have shifted to the left 3. Then you'd have to remember this weird thing about that. So instead, they make it so the number comes out the way you expect to see it on the graph. But that forces them to have a minus sign there in the formula. Okay? So here, the vertex was at negative 3, 0. And then here in number 7, the vertex was at 2, 0. So how would we summarize what h does to the graph, or what it tells us about the absolute value function we're graphing? Yeah, go ahead. Good. So it moves the x-coordinate to the right or the left. So that means two things in the way that he said that. One, we actually get the x-coordinate of the vertex from the h value, right? H value, x-coordinate of the vertex. Two, he said it moves it to the left or to the right, meaning it causes a translation also, but this time it's not a vertical translation. Instead, it's a horizontal translation. Okay? So when I summarize what h does, I would say h causes a horizontal translation. And again, if those words aren't sitting well with you yet, you need to make a note that that means a shift to the right or to the left, but we want to get good at using the proper terminology. It also gives us the y-coordinate, or excuse me, the x-coordinate of the vertex, meaning the vertex will always look like h, comma, whatever. So if you know that h is helping you with the x-coordinate of the vertex and k is helping you with the y-coordinate of the vertex, we can kind of summarize that in our absolute value equations, we can find the vertex by pulling together the h for the x-coordinate and the k for the y-coordinate. That's pretty powerful information because now that means without a calculator, I know where the vertex of every absolute value function is if I could just get it written in the right form, right? If I can get it written in the right form and pull out the h and the k, I immediately have the vertex. If I can look at the a and see if it's positive or negative, I immediately know whether it opens up or down. And then how am I going to know how steep to make the sides of the absolute value graph? A, right? A was determining the slopes of those sides because they were lines. So we can actually do all of this by hand without our calculator having to do it for us, which is our goal, okay? So, like was pointed out by Kyler earlier, we are having a quiz on Tuesday, but only on graphing absolute values. Hopefully, by doing the investigation, usually people catch on pretty quickly to what that looks like. we're going to have time in class for you to do the homework today after we go through a couple examples. And you have Monday that you can come in for tutoring or anything that you need before Tuesday's quiz. I tutor in my room on Mondays during 6th period and after school. So basically from the start of 6th period all the way until 3:45. There's also tutoring in the library from 3 to 4 on Mondays and 3 to 4 on Wednesdays. Okay? And then by appointment if you're really struggling but the times don't fit into your schedule or whatever. Okay? You can come talk to me and we can try and set something up. All right? So Monday, if you're really struggling with your stuff and you're worried about Tuesday, you could come in on Monday and see. All right, so at the bottom of this, there's a couple examples. So example 1 says, what's the equation of the absolute value function? It might be a little bit hard to see up here. I think you can see it pretty good on your paper, maybe not. So basically, that would be the x and y axis. This says 2, which tells me it's numbered by 1s. Okay, because that's the second tick mark there. If this one's not labeled, I'm assuming that it's by 1s. Okay. So remember, to write the equation, we're looking to set something up in this form where we can identify A, H, and K. So who can identify something for me from the graph? Yes?
H is 2.
Good. Here's the vertex of our absolute value function. Okay. It's been shifted 2 to the right from the origin, so H would have a value of positive 2, which means when I plug in positive 2 inside the absolute value bars, it looks like x minus 2. Okay, because positive 2 has just been inserted where H is. All right, what else do I know? Yes?
A is equal to 3.
Okay, so A is equal to 3. So let's see. If A is the slopes of the lines, right? Pick one line to look at. Here's one. Okay. Remember, to find the slopes of the line, you have to be able to go from one clear point on the line to another clear point on the line. I don't see it passing through another clear point until there, so I'll use that one. So to get from one of these to the other, the rise would be 1, and then the run would be 4. So the slope of those lines is 1/4. Am I going to do it as a positive or a negative number in this equation? Positive. How am I making that decision? Good, because it opens up. Because really, one line's going to have a positive slope, but the other one's going to have a negative slope because it's 2 lines going in opposite direction. So you can't let that determine positive or negative. It's does the V open up or does the V open down? So this is going to be 1/4. All right, what about the K value then? That's the last thing we need. 1. Good. It has a vertical translation. It's been shifted up 1 from where it was originally at the vertex. And if you look at the coordinates specifically of the vertex, you can see that was your H and that was your K immediately. And we used the slope to find the A value. Okay. Once you learn the structure of them, not so bad, right? Okay. So that's why we can graph them by hand really quickly. All right. So what if we're going to go about graphing this one? Ideas of what we would want to do first. So we have y equals negative 1/2, the absolute value of x plus 3 minus 1. Yes? Good. Find the vertex. We've learned that that's something we can pick out fairly quickly from the graph. And in this case, what is the vertex? I'll let you tell me. I agree with the negative 1. And I agree the number there is 3, but is it positive 3 or negative 3? Negative 3, because remember it's x minus h in there, so it's kind of the opposite of what you're looking at. So negative 3, negative 1. Sorry that my graph is really small. Okay. Negative 3, negative 1. Is this absolute value graph going to open up or down? Down. And how do I decide how wide to make those lines for the V? The slope. And in this case, the slope is negative 1/2. So I'm going to go down 1 over 2. And down 1 over 2 the other way. Oops. And that's my graph. That's it. So again, this is why we use the calculator first. By putting all those graphs into the calculator, it was easy to see like the patterns. And once you have the patterns, it's a lot easier for us to understand how to graph it ourselves. Okay? All right, so number 3 has kind of a hiccup. Okay? What's the problem with the way this looks compared to the structure we're expecting? Yes? Good. as of right now, there's no A value, but what is there that's kind of messing stuff up? Yeah, in the absolute value, we only looked at a formula where it was like x minus or plus something, no multiplier in front of it. But the thing about absolute value is would you guys agree that these are the same things? This is the property of absolute value because of how it behaves. Whether I multiply the 4 times 6 first and then turn it all positive, or if I turn everything positive first and then multiply it together, I'm going to get the same thing, correct? With multiplication. Could I do this with addition? No, okay? Because that would definitely be different if there was some negative stuff inside before we turned it positive. But with multiplication, it's fine. So what we can do with absolute value is we can think of that 2x minus 4 as 2 times x minus 2. Meaning even if 2 didn't go evenly into 4 and factor out so nicely, whatever number was sitting in front of x, I would factor it out, even if that leaves a fraction or something else in here, because I'm trying to get it to look like this, meaning I don't want any coefficient here. So whatever the coefficient of x is, factor it out, even if it leaves a fraction or a decimal in the second term there. So plus 3. Then this can really be like 2 times x minus 2. Which is fair to do because of the property we talked about right here. Okay? What's the absolute value of 2? 2. And now we can graph it like we graphed it before. So what's my h value in this equation? 2. Good. Positive 2. What's my k value? Somebody knew. Yes. 3. Good. So this is my h. This is my k. So my vertex is at 2, 3. Okay. What's my slope for my lines? Someone knew. Yes. 2. Is my v going to open up or down? Up. So I'm going to go up 2 over 1 and up 2 over the other way 1 like a mirror. Yeah, sorry about the line in between. That should not exist because my little pen is running out of batteries. Is this all right? All right, so same idea in number 4. Can somebody tell me how you're going to adjust the equation before we go to graph it? Okay, so we want to factor out that negative 1/4. What do you get when you factor a negative 1/4 out of plus 1? Good, negative 4. Okay. Couple ways to do that. Either you have to think in your head, what times 1/4 would have given me 1 right there, or you have to take 1 and divide it by 1/4, and if you do your fraction division algorithm from like elementary school, then you'll get this. Okay? So again, this can be written like this, where this number we can actually take the absolute value of. So it's just going to be 1/4. All right, so h value. Somebody knew? Yes. Good. H value is positive 4. K value? 2. So my vertex is at 4, 2. All right, opens up or down? Up. Okay, with the slope of 1/4. So up 1 over 4 and mirror it the other direction. Absolute value graph. Okay? Not that bad once you understand how the equation works. Okay. Are we all right with this? Any questions?